So June 2017 paper. Which of the following is a vector quantity? So distance is not a vector, speed is not a vector, velocity is a vector. So C is the right answer. Which of the following is a unit of upthrust? Upthrust is a force. Upthrust is actually a force. And what is the unit of the force? The unit of the force is Newton. So D will be the right answer. Upthrust, tension, these all are the forces. When force is applied across the end of a sample of a wire, the wire extended until it fractures. The force in extension graph is shown. The force is applied to an identical sample of a wire and then removed. If a sample of a wire is to return to original length, what is the maximum force that can be applied? Like we should be within the elastic limit. So which point appear to be elastic limit? Z is a proportionality limit. Why? Because this is the last point where the line is straight. And after proportionality limit, we'll have elastic limit. So which point is elastic limit? Y is the elastic limit. Like after this, if we cross this point, the object will not return back to the same original length, shape, or size. And this X is called a yield point. Yield point means for a small change in force, there is a greater change in the length. That's called a yield point. In question 4, a stone of mass m is dropped into a pond and accelerate downward with an acceleration. The free body force diagram for a stone is shown. Which of the following? So as I mentioned, when we drop, it accelerate downward. So downward force is more. So if downward force is more, it means mg minus the upthrust minus the drag is equals to ma. Why we are saying it should be equal to ma? Because it mentioned it is accelerating. If this was moving with a constant speed, then the result, the upward forces minus the downward force or downward force minus the upward force should be 0. So whenever, according to Newton's law, whenever there is a resulting force, the object will always have acceleration, ma. This is when the object is accelerating. If the object is moving at a constant speed, then the resultant force is 0. So because they mentioned it is accelerating down, so it means there should be a resultant force, a downward force minus the upward force should be equal to ma. So mg minus upthrust minus d is equals to ma. So d is the right answer. A student throws a ball vertically upward and catches it after 4 seconds. The student data is used for velocity and time. Using the graph, what is the acceleration? So gradient, the slope of velocity time graph, which is equals to, and you can, because it's a straight line, so I can take v minus u over t. So final, if I take till this point, starting is this 15, final velocity is 0. So 0 minus 15 divided by time interval, that's equal to 2. So basically we'll get a negative acceleration, which is 7.5 meter per second square, or we can say this object is decelerating or speed is decreasing. Then using a graph, what is the total distance? Look, this type of graph, sometimes they ask total distance, sometimes they ask displacement. If they ask for total distance, area of the graph, area under the graph will give us a distance traveled. So we'll add the area of this part. It is making a triangle, so half base into height. And this is also making a triangle, so that is also half base into height. So it will be half, base is 2 and the height is 15. And here also half, base is 2 and height is also 15. We are not taking the sign here because distance is a scalar quantity. So this is 15 meter. This is also 15 meters. So total distance travel will be, so if they ask in the question, sometimes the similar question they ask displacement, sometime distance. So distance, we will add them, so 15 plus 15. But about the displacement, we'll subtract because they are in opposite directions. So 15 minus 15, so it will be 0. So according to the question, they are asking for a displacement, total distance travel. So we will simply add. So we'll get C as the right answer. If it was a displacement, then we will subtract the two to calculate the displacement. An object of weight W is on the slope which is making an angle theta, the normal contact force. If theta increase, what happened to R? How to identify first? Whenever object is on the inclined surface, we'll resolve this into components. So it's making angle theta here. So there will be a component of a weight, the one which is with an angle W cos theta on inclined surface, and against the angle will be W sin theta. So because W cos theta is balances with the R, so we can say R equal W cos theta. Then they're saying value, so R equal W cos theta, so either A can be an answer or C can be an answer. Then what happened? What is the relation between theta? Always remember, theta is directly proportional to sin theta. Like if we increase the value of theta, the value of the sin theta increases. And theta is inversely proportional to cosine theta. So if the cosine theta increases, the value of the cosine theta will decrease. So what happened if, as I mentioned, if the theta is increased? So if we increase the value of theta, what happened to value of cosine theta or cos theta? That decreases. The value of the cosine theta decrease, so the product will also decrease. So value of the R will decrease, and what is R? R is actually equal to W cos theta. So A is the right answer. Next one, a cylindrical weight is there, 1.5 Newton. It is placed on the top. The spring compresses 3 centimeter. What is the spring constant? All the unit in Newton meter. So we have to convert this into meter, divide by 100, so 0.03 meter. So spring constant F is equals to Kx, or K is equals to F divided by X. The force which is applied is 1.5, and the decrease, the compression here, which is 0.03. So 1.5 divided by 0.03, so this will give us 50 Newton per meter. D will be the right answer. Then the path of a projectile is shown. As you can see, this is a trajectory or a path taken by a projectile. The projectile landed at a height lower than, so basically when we launch a projectile, velocity here will be same as velocity here. Horizontal component at this point will be same as horizontal component at this point. Vertical component, direction will be opposite vertical component, but it will also be same. But it does not reach this point, it is lower than that. And there is no air resistance. So assume there is no air resistance. Which of the following is true? At maximum height, the horizontal velocity is minimum. That's wrong. If there is no air resistance, horizontal velocity does not change. So that's why A is not the right answer. At maximum height, the vertical velocity is maximum. That is wrong. The vertical velocity is minimum. At maximum height, the vertical velocity is always zero because the projectile is moving horizontally. It does not move vertically at the maximum height. Initial horizontal velocity is equals to final horizontal velocity. That's true. That the horizontal velocity does not change. It remains same throughout the projectile if the air resistance is zero. So C is the right answer. Why not D? Initial velocity is equals to final. It won't be, because if the projectile land on the same level, then the initial will be equal to final. But in the question, it landed a bit lower. So it means its velocity won't be same. Constant resultant force act on the object. Which of the following graph shows a motion? So whenever we know force and acceleration are directly proportional, so resultant force is directly proportional to acceleration. They mention force is constant. If force is constant, what happened to acceleration? It should also be constant. Here, distance time graph, the speed represent the slope. So speed is constant. And if speed is constant, acceleration is 0. Velocity time graph, but this is a velocity and distance graph, so it won't give us the result. Velocity and time graph, slope represent acceleration. So acceleration is, or slope or acceleration is not changing. So we can say it is constant. So these also, so C is the right answer, that the graph which shows that acceleration is constant is C. So this was from June 2017.